And in addition to DataStax Enterprise, we also have kind of this new hyper-converged database and platform that we'll be talking about as well. So
yeah, you get to learn what the hyperconverged actually means. So that's good. Yeah. But why don't we get moving here? Everyone's on a schedule, including us.
So, of course, Patrick and I, when we talk to folks out there who are using Cassandra or using DataStax Enterprise and maybe haven't quite started their Gen AI journey, we get a lot of questions like this. Like, hey, we want Gen AI, but we want it in our data center. What's our path forward? How can we have our on-premise feel more cloud native? How can we do this?
Yeah, that's the thing. I mean, it's because I think with Gen AI, it's all been pretty cloudy. It's not been a ton of on-prem, but right. There's just requirements. And when you have those requirements, you're stuck usually because there's somebody else making that decision for you. So we're going to help.
Yep, that's the plan. All right, so this is kind of what we're going to talk about today. We're going to talk about DataStax Enterprise 6.9. We're going to talk about HCDP, as well as two great features that you get with both of those, DSE 6.9 and HCDP. You get the data API and vector search. And then, of course, kind of a plea we make to our current DSE customers and community is, hey, why should you upgrade? So that's going to be our plan.
Let's do it.
All right. So I guess we start with Patrick.
Hey, if you don't know who I am, I've been working on the Cassandra project for about 12 years now. I'm a committer on the project. I'm also involved in a lot of distributed computing infrastructure stuff. Wrote a little book, Cloud Native Data on Kubernetes, with Jeff Carpenter, who also wrote the Cassandra book. Recently, I've been working on LangChain and Llama Index on a Cassandra database tooling for agents. It's kind of a fun thing to get into to enable that. So yeah.
All right.
On my LinkedIn. Follow me on LinkedIn, or feel free to connect or follow me on LinkedIn.
I was thinking about the opening slide where it shows, kind of the title, and then it shows both you and me, and it says Patrick McFadden, VP Developer Relations, and then Aaron Pletz, Developer Relations. It's like, here's our VP and the guy who gets his coffee is kind of how that looks to me. But
and I'm empty. Kidding. I'll get your copy. I'll be right back.
Oh, that'd be awesome. No, just anyway. So I'm Aaron Pletz. I work in developer relations at DataStax as well. I've also written a few books, mostly in like the NoSQL space, but this last time I actually did write one on Java, which was a lot of fun, by the way. I also do the
latest Java.
The latest Java. Well, technically, I think 22 is out now, but 21 is the latest LTS version.
LTS,
so I'm cool with that.
Okay.
Yeah. Hey, I also host the Apache Cassandra Corner podcast. So if you have any great use case stories or anything, hey, reach out to me. I'm happy to talk to you and build out a new episode for you. And hey, as far as like Gen AI stuff, I actually did work on that Swifty GPT project that we put out back in December. I think we released it on Taylor Swift's birthday, but I kind of put together the initial model and back end that talked to Cohere and all that, and did a lot of scraping of Taylor Swift web pages. Yeah. So that was that. But it works good. People still use it.
Let's dig in then. Well, because now we're the most experienced Gen AI people out there now because we've done it for more than 10 minutes.
Right.
Yeah. All right.
So, hey, starting out, DataStax Enterprise 6.9. It's the most recent version of DSE we have, the most advanced DSE ever released, which is saying something because, I remember I actually did Granger's first install of DataStax Enterprise. I think it was version 3.2, and this was like 12 years ago or so. So it's really come a long way since then. You get the improved indexing, storage attached indexing, that we've had in Astra for quite a while. The cool thing about SAI indexing is that it really does kind of make vector search possible. And vector search is, again, something else you get with DSE 6.9. DSE 6.9 also will finally get you past Java 8. It has support for Java 11, which is a huge step forward. I talk with folks in the Java community all the time, and it's always like, oh, we got to get people off of Java 8. And really it's a lot of the legacy enterprise apps and things that are kind of stuck on it. Well, not anymore for us. So that's pretty cool. And of course, we also have the data API. We're going to talk a lot about that later, but basically it's kind of an easier, more intuitive way of accessing data and building data structures. So I mentioned this, hey, DSE 6.9 runs on newer Java. You get improved JVM profiling, access to the newer garbage collectors that everyone's talking about, like Shenandoah and ZGC. And hey, you get, transport layer security 1.3 certificates. Again, for a while, we've been stuck on 1.2. It's like, hey, 2008 called and wants its SSL certificate cipher back, please. So
this is why people complain about Java, because they're using the version from like 10 years ago, right?
Right.
Yeah. If you're using like the later versions of Java, it's pretty amazing.
Yeah. Absolutely. It's a huge upgrade just in and of itself. I mean, performance-wise, yeah. All right. And of course, improved indexing, again, we're going to talk about this quite a bit. It significantly improves disk usage, and by significantly improve, I mean uses a whole lot less. Allows for the use of like text analyzers, so you can do like case insensitive searching, and there are some other options that you can do along with that as well. And it also gives you the OR operator. How many times have people in DSE and Cassandra in the community have come to me and said, "Oh, you know how great it would be if we had an OR operator." And now we finally have one. So yeah, that's pretty cool. And then, hey, SAI, it's we're going to get into this more, but it's the backbone of vector search. It really does make vector search possible. So yeah, this is one of the bigger things that you're going to see in the new DSE.
Well, and I think it just kind of cap off the DSE thing here. It upgrades your whole entire Cassandra experience too.
Yeah.
And get you on things that have been there's just thousands of improvements that have been in the project for a long time. So it gets you up to date on a lot of things. These are just the highlights.
Right. Exactly. All right, Patrick, I think we go to you now.
The old Hyper-Converged Data Platform section. All right. So what is the difference? So we have DSE 6.9, and really I'll just start this by saying DSE 6.9 is your in-place upgrade. It works with Op Center, it works with your current existing systems with DSE. That's an easy upgrade for you if you're currently on DSE. But this hyperconverged database track that we've started is really the new version of where we're going with an enterprise version of Cassandra, because it's more than just an enterprise version of Cassandra. But this hyperconverged part of it is putting together all the things that you need for building applications, and this is based on our experience by building Astra. So if you're familiar with Astra is a Cassandra as a service that we offer, but it's not just Cassandra. There's a lot of little things that are connected to it, which make your overall application stuff better. So your life is better using a group of things instead of just one thing, right? And so like this part of the database, like vector search, which is available on Astra right now, the data API, which is available on Astra, but this is things that you can run in your own data center. The real difference with this hyper-converged part, next slide, is where the roadmap is going.
That's
and
right.
Why this is very different. And so if you're looking at like the future of on-prem data platforms, this is where we're going. So DSE 6.9 will be the end of that. And you'll eventually need to start moving over to HCDP, which is jumping tracks over to the fast track into the future. And there's an upgrade path. We'll help you do that. That's not a problem. But if you're just being conservative about your upgrades, we get it, DSE 6.9. But what are you going to get if you get on that roadmap? And that is the key, right? And you want to be on this roadmap eventually, because it's big, right? We have just recently announced our partnership with the OpenSearch Foundation at AWS, and we're going to be doing a lot of work with them for integration. And so OpenSearch will be added into that platform. Also, the streaming portion with Pulsar, which gives you a Kafka topic, so you can work with that inside your data center. But the thing is, it's like it works with Cassandra directly. So if you think about like CDC as when it gets the most useful, you know, the change data capture. So when you insert data into your Cassandra database, it emits the change. Well, there's two places that are really useful we found, and that is dumping it into a search index like OpenSearch, or putting it into a topic that can be picked up from other services like microservices, or if you need to stream it into some data warehouse or whatever, you come up with your use case. But the integration is the key. So you don't have to go out there with your screwdriver and your wrench and everything and build all the stuff yourself. I know you can, I know you want to, but this is a time saver. It's just meant so you can plug and play and go. And that's really what this data platform is about. Now, what does that mean? Like, why is it different, or what's the big thing for you to know about this? Next slide is how we deploy it. And because this is a pretty complicated deployment, meaning that there's a lot of services that interact, that have to have services connected with IPs and everything else, Kubernetes is the way to go.
That's right.
If you don't believe me, I got a whole book I wrote about it. But yeah, so HCDP will only be deployed on Kubernetes. So mission control is the thing we're going to, and Aaron has a lot of great content about mission control. Mission control is the newer version of what we've stopped Ops Center at DSE. Mission control is HCD. And mission control is a Kubernetes-based control plane for running your data plane. And that includes Pulsar and OpenSearch. So you'll be able to deploy some really cool things for your developers, and in one very easy way to go. And if you're not using Kubernetes, I know, and I know who you are. I know who you're screaming at right now, but it is something you should consider because it really is the future. And if that's all I can say about it. But it does full lifecycle management, repairs, backups, that sort of thing. It manages across clouds, across on-prem, across both. The encryption stuff is all automated. I mean, it really makes
huge in and of itself. The encryption part, oh my God, that was always a big pain in a large cluster. But yeah, anyway.
Yeah, I mean, node-to-node communication is all encrypted and it's managed automatically. Yay team. Okay, so those are our products. But I think, Aaron, we should probably dig into like some of the really cool things.
I think the data API. Yep, here we go. Data API. Yep. So we've talked about this quite a bit, but if those of you who have used Astra have probably used this before. It's a different way we have of allowing access into into data that's usually inside of DSE. In DSE you're used to the whole like key space, table, row way of getting at your data. Well, this is a little bit different. This gives you a like JSON-based API interface. You can update it with like Postman or curl commands or whatever you like. But we actually do have some API clients that are available for a lot of the major languages that we support. And actually, I'll show you a little bit in one in the demo coming up.
Well, but again, mentioning Aaron is they're like, oh, is this a completely new thing? No,
but it's new for DSE.
It's new for DSE, but if you're already using Mongo, this is compatible with Mongo.
That's right.
So this is you can take a Mongo application, point it at this database, and it'll work.
Yep, that is a good call out. Yeah, that a lot of work's gone into kind of appreciating that ease of access that Mongo's had. So yep.
Yeah, and I mean it's of course that it's trying to be lockstep with Mongo is going to be very difficult, but we know that a majority of developers prefer that, and it's just easy to work with. So if you are sick of data modeling, don't do it.
Yep. So kind of like I said, the nomenclature changes a little when you're working with the data API. A key space kind of equals a namespace, a collection kind of equals a table, a document kind of equals a row. So just that, yeah, when you start working with the at the data level in the through the API, that's kind of the new naming structure that you're going to see. And again, it's just to be more consistent with what's out there. But the idea too is that it kind of gets you away from having to care about bucketing and partitioning and a lot of the things that have really just made life difficult for Cassandra developers in the past. All right. Well, I think the next thing on here is to show you some of this. So let me go ahead and get that kicked off.
And we're not going to do a live demo. We talked about this. It's like everyone that has been in tech, that live demos are doomed. So Aaron recorded it so we can just play back that demo and be so much more relaxed. And you'll get better content.
Okay, so I'm going to have to... Oh, it's not letting me just jump to a different tab? Okay.
Well, you have to share a different tab.
Yeah, I have to share a different tab. Okay. And also share tab audio. That's important.
I'm glad we practice this. Yeah.
I know. Okay, here we go. I'm going to demonstrate the data API here with an install of HCD. And I'm going to use mission control to start some things out here. All right. So as you can see, I have a cluster here called Rush 2112 with a data center named Megadon. And that is data API enabled. All right. So we are going to go and connect to this thing and use the data API with Postman. That is going to be our way in here. So let me try and increase the font size a little bit there for y'all. Just starting out, first of all, we need a namespace or a key space defined. So I'm going to go ahead and use this create namespace endpoint. Now I want my key space to be properly replicated, so I'm going to make sure I'm picking network topology strategy and then specify my data center of Megadon with a replication factor of 3. Now, if I run this, okay, we should be good to go. Now, if I want to actually put data into it, I need to create a collection. A collection is really just kind of a fancy document API name for table. So I'm going to use this create collection command, and I'm just going to name it library. So here, I'll send that. Okay, so now we have a collection named library. So what if I go into this collection and I want to insert a document, right? So I'm going to, we're going to have this, this library be full of data about books. So in this case, I'm going to insert data for the book Code with Java 21, which admittedly does happen to be one of mine. All right, I will go ahead and just do an insert 1, and then I'll specify my document like title, author, image, publisher, and then we'll run that. All right, and I get this UUID as a return value. This is the ID that inserted. Now you can also update in place. So if I go to update 1 here, what I can do is say update 1, and then in my filter, I'm going to specify the ID of the document I want to update. And I'm going to add the fields of ISBN as well as a link to this book's page on Amazon. All right, there we go. So now I should also be able to do a get 1. Yeah, here we go. Do find 1, and let me paste that ID in there. And when I run this, there we go. We have our Code with Java 21 book. Outstanding. Now, instead of just inserting 1, I can also insert many. And here you can see I have plenty of books that have been written by other folks here at DataStax. So I'm just going to run this whole thing. And look at that. We inserted 5 new records and received those IDs back as well. So, hey. Now, in addition to doing a get 1, I can also just do a plain old get with an empty filter. And I can send that through. And sure enough, that pulls back every document inside the collection. All right. So with all of that data available, I can actually jump over to this this application I wrote called DS Books. And here you can see I've just built a simple front end for going through our data, connecting on out to HCD with our Cassandra token and our HCD Cassandra endpoint. And that's really all it takes. It's very similar to how it works with Astra, which is why I kind of mixed up my words there. So if I run this, okay, now I can say 127, what do I want on 8080. Okay, and as you can see, we have our DS Books application, and you know, we've built our menu here by just doing a straight out get. And I can say Practitioner's Guide to Graph Data. You can see this is by Denise Gosnell and Matthias Broschler. You can see Cassandra, the Definitive Guide by Evan Hewitt and Jeff Carpenter. You can see Managing Cloud Native Data on Kubernetes with Jeff Carpenter and Patrick McFadden. So yeah, so these are all out here. And this is the data that we've just inserted and managed using the Data API. All right, let me reshare things again here.
It was weird, man. I was like, Inception. I see two errands.
Yeah, I was in two places at once, right?
Yeah. So why don't we talk about vector search?
Yeah.
Vector search. Okay, I don't expect a lot of you to know what that actually is. You probably heard plenty of talk about it, but and if you know everything about vector search, just do something else for a minute. But vector search is just that. It's a search paradigm. So we have plenty of search paradigms. You can do very we have this very clear thing like, oh, you can look up by partition key and get the exact answer. You can use indexing on a field, so you can look up extra fields. You can do range searches. But then we get into things like text search, like is there text in this document, BM25, which does ranking. But now with vector search, it's a completely different, like we're way over here. We're starting to move into the fuzziness of it. And that's the semantics. Like, how is this thing similar to that thing? And that's a tougher problem. But thankfully for you, plenty of nerds before you have figured out how to make this a lot easier. And so vector search does this thing where it finds objects that have similar, and objects being text, it can be video, audio, whatever, but it understands the meaning, and then it says, oh, I'm looking for a red shirt. Okay, that's up here. So, and here's a bunch of things that look like a red shirt. Next slide, please. And the key to this, and this is what's really interesting, is that a vector, when we store it in the database, is just an array of a lot of numbers. And so it could be, when I say a lot of numbers, very typically a vector array can be 300 terms or maybe 700 and so. The Apple, or not the Apple, OpenAI, they're almost interchangeable at this point.
Right.
OpenAI ADA is like 1532, and it can be like 2048. So that's 2048 terms in an array. That's a lot of numbers. But what that does is it gives you some resolution. And so when you say, here's an image, and here's 2048 different coefficients that could describe it, that gives you a lot of resolution. So when you're looking for something exactly. The key, though, is that when you store a vector and it's indexed in the system, you have to present it with another vector to compare against. And that's probably the biggest difference. Is this isn't like an indexing scheme like whenever you create an index in a regular database where you say, here, create index, and then I'll give you a word, and you tell me if that word is similar to an index. No. The embedding is a critical part of this. Now, right. In Astra, we create the embedding for you, and I expect that'll probably happen sometime in DSE. But this is where you have to create the vector, present the vector to the system, and then that vector, it'll start doing the similarity search on vector versus everything that's in the index. So that's how this works. So next slide, please. And what these embeddings do is they take things like much bigger things, like a chunk of text, a paragraph to text, and it derives as semantics, for instance. Like, so if you say, what was this about? It wasn't like a keyword search where you're looking for the word token in every document. That'd be something you do with like Lucene, any Lucene-based indexing, like, Elasticsearch, OpenSearch, that sort of thing. This is more the semantics, like, I want to hear about the ways to manage my security. Okay, well, there's meaning in that. And these embeddings are really cool because they can derive meaning from text. And then they create the embedding, and that's what you're searching around. So think of all those use cases that you could do with that. And if you haven't, here, let me provide some for you. So next slide. The common use cases that we've seen so far are just regular enhanced search. Like, think about like what that looks like, what that would look like for you as a search paradigm. It adds to your toolkit of search, nothing that you've had access to before. And if you have had access to it, you probably had to build it yourself. Enhanced matching, that personalization, and the personalization has always been a thing in e-commerce, but how about fraud detection? Like, ooh, this looks stinky similar. Like that fraud detection is actually a really cool use case for vector search. Some analytics like classification. I've done this before. Like, is this thing similar to this thing? Great, put them together. And the conversational interfaces, you've used ChatGPT. Everyone's used it. Probably used Gemini as well. All the chat interfaces use vector search to, like, you upload a PDF and then you can ask questions about it. There you go. You just use vector search. So that's the use cases. So what is, like, next slide. What most people are building right now, and this is what you see, is the RAG application. And that RAG is retrieval augmented generation. And, because nerds like to put a lot of words into a name. But
and they like abbreviations too.
Oh yeah, three other acronyms are amazing. TLA. So RAG is probably what you've been hearing about when it comes to like using a vector-enabled database. And vector is it's not a differentiated feature anymore. Every database in the world does this now. So FYI. But what RAG does is it takes like a question from a user, and instead of using a large language model, large language models are like GPT-4 or Llama 3, instead of just relying on the LLM to give you information back that may be embedded somewhere in that thing, and then what would you get? These wild hallucinations, like putting glue on a pizza. If you haven't heard about that, look it up. It holds the cheese on. Instead, it uses that vector-enabled database, in this case, your DSE or HCD database, to pull in semantically interesting information. So think about personalization. If I want to know about all the things that I've done at, say, like your e-commerce site, that my data can be looked at, and that can be augmenting the response. So like, hey, what did I buy last week? Well, here's all the stuff that from the shopping cart data from last week, and then feed it into an LLM. Why feed it into an LLM? Because it does really nice textual responses. It creates a language, like human language. So it would say, hey, based on your spending habits last week, you were out of control. I don't know if the LLM get judgy, but it could. But that's the point, is we use the LLMs for language and interface, and we use the vector embedding for the actual information, so we minimize or reduce or even remove any hallucination. So this is the thing you probably want to build, or your developers want to build. Next slide. And then finally, why this is super awesome inside of what you're getting with DSE and HCD, because you lucky dog, you get to use JVector 3. JVector 3 is the most advanced vector indexing engine out there right now. And I'm saying that with almost zero marketing eyeball, because I've been watching it work. You'll notice that the GitHub repos, Jonathan Ellis, who those of you in the Cassandra world may recognize that name. Well, guess what? He spends, a couple times. Yeah. Guess what he spends like 28 hours a day on? Yeah. Building a vector indexing scheme. You can go look at the code. It's all there. Now, JVector 1 is in Cassandra 5, but dude is moving fast, and he's trying to stay way ahead of the curve on the research around vector indexing, because there's a lot of research on it. And so we're already up to JVector 3, and I'm sure it'll be JVector 4 by next week. But
Yep.
we're constantly updating. We're putting that in line with DSC and HCD, so you can have the most recent version of this vector indexing engine. Why is this important? Because vector indexing is a heavy operation, and we are trying to make it as lightweight and cheap as possible for you, and make it fast for your users. It's not an easy thing to do, but we made it easy for you. Okay, and so, oh, by the way, this is a comparison against Pinecone. I didn't put the who does this getting compared to? I think this is Pinecone. Yeah.
Anyway, quite the throughput difference there for sure. For sure.
Yeah, well, whatever. Just put up a graph that makes it look amazing. You know what? Don't
that's
trust
easy,
me
right?
at all. Go try it yourself. Yeah, you can do it. All right, next slide.
All right. Well, I think we're back to me stepping into the multiverse again. And
yeah, it's pretty cool.
Yeah.
I mean,
doing another. This one's much shorter though.
Are we gonna break the universe?
Can that break the universe? I don't know.
Yeah.
So for this demo, I'm actually going to do a much smaller example. The vector dimensions we're going to work with are only like 2-dimensional vectors, so it'll be pretty short. But the idea is that they're meaningful and then they can still drive results. So let me go kick that off. Actually, let me share my my tab first. Oh, there it is. Okay. All right. And here we go. Oh, wait a minute. Why does that look like the wrong one? Ah, okay. Haha. There we go.
You didn't share the audio.
It's not doing audio?
Nope. But it looks great. Yeah, that's why we're doing it live, folks. So you can see us do these things.
Womp, womp, womp. Okay.
This is what's funny. I said we recorded, so we missed the live demo. Like we didn't upset the live demo gods.
Yeah, now they're getting back at us.
Yeah.
Okay, so I have, data API vector demo, and also share tab audio. Okay. You don't hear it?
Yeah, I don't hear it. I don't know if anyone out there, maybe I'm wrong. Nope. Can't hear it.
Okay, so you know what I'm going to do is I'm going to get rid of the other one because I think that was getting in our way.
You know, have you tried turning it off and turning it back on again?
Yeah, I haven't gotten to that point just yet, but I'm getting close.
Yeah.
Okay, share screen. All right, Chrome tab. Yep, there we go. Also share tab audio. That's on. It's on. All right, Patrick, you got to let me know if you can hear it. All right. So now it's not running at all. That's great. Okay. Let me try. Okay, yep, there's that. And I'm going to drop that. Where did that go? So Patrick, now I hear you.
Now I'm off mute. Well, I muted because I didn't want to like overstep your thing. So let's talk about one thing while you're, rebooting your computer. A lot of people have asked me like, what's going on with these updates and open source Cassandra? So we are donating upstream all of these things. Actually, some of it exists. The data API exists in Stargate, and JVector is indeed in Cassandra 5.0, except it is JVector 1. So it will be upgraded over time, but the pace of the project is a little bit slower. So that's part of the thing. And the other thing is we do all the integration. All the integration is there for you. And we give you all the bells and whistles around the enterprise stuff like support and that sort of thing.
Excellent. All right, let's try this again. This time, but really, I'm just going to show how you can do a lot of the same things that we did with the data API with Vector, and how vector is exposed through the data API if you want to work in a pure vector solution. So if we're going with our DS Books example, maybe I want to add a vector search component to it. So in that case, what I need to do is add a vector-enabled collection. So I can do create collection, and I'm just going to call it library vector. But my options, I'm going to set vector, I'm going to set for 2 dimensions, and I want this thing to be indexed with a Euclidean mechanism. So I'm going to send that. Okay, so we've got our collection out there. Now if I take a look, I have this insert many vector method inside of Postman here. And you can see here I have insert many, and I have the documents kind of filled out, but I have this vector component on here. Actually, I can bring that down a little bit so we can see each whole document here. But basically, it's the same data, but each one has been given a vector on the bottom. And if I just go ahead and run that, you can see that I get my IDs back here. So we have a successful insert. Now, if I want to try get by vector, you'll see that my find is a little different, where I don't really have a filter mechanism anymore. I just have a sort mechanism. I'm going to do an insert or an include similarity true here because I want to see the similarity scores. So I'm going to say, hey, do a find. We're going to sort on the vector column, and I'm going to use that first vector position of 1, which means published by O'Reilly, and then a number 3, which equals subject of NoSQL. And I'm going to do a limit 5. Actually, maybe we'll do a limit 3 on that. How about that? And then I'll go ahead and we'll send that. And what do we get here? Okay, so the first one that comes back on NoSQL from O'Reilly is Cassandra, the definitive guide. So hey, that worked. And you can see that has a similarity score of 0.96, which is really, really good. Next, we have the Practitioner's Guide to Graph Data. Hey, that actually did hit because we did search by NoSQL. And this is an O'Reilly book for sure. And then we have 7 NoSQL databases in a week. That's one of mine. It's not an O'Reilly book, but the NoSQL subject is a direct hit. And that came in at 50% similarity, but yeah, you know. Anyway, so there's a quick demonstration of how we can use a vector through the data API.
Yes.
All right.
Yes. All right, home stretch.
Home stretch. Yep. Let's get the last of the slides here now. This doesn't have anything complicated like audio, so this ought to be pretty simple. But here we are, Patrick. Why should you upgrade? That's
always a question.
Yes.
I don't want to because the thing that I got works great, right?
So, of course, Patrick had never seen this meme, but I can hear this. Upgrade. Actually, that's Jim Foy being asked about the playoffs at a press conference after just getting beat, but that's okay. But yeah, why would we upgrade? Well, going to DSE 6.9 or HCDP gets you obviously best-in-class enterprise databases. Support with GenAI for vector search. I mean, this is probably the big thing. You know, it really lets you get into that next level, get into that cutting edge of current tech that everyone's kind of jumping on the GenAI bandwagon. And if you want to start going ahead and innovating in that area, DSE and HCD will let you do that. Simplified access with the data API. And simplified ops with mission control. You know, Patrick, I'm hearing that word there that's common. Simple. Simplify.
Well, that's the upgrade. Yeah, the only reason you should upgrade is if it makes your life better, right? And
that's right.
This is a famous quote that I love, which is progress in technology is when we have the ability to be more lazy. And so the thing that's going to happen is that your users, your developers are going to ask for these features and you're going to have to figure it out. This is the easy path because you already have something that works at world-class levels that you just need to upgrade and do, instead of rebuilding an architecture or finding new products or vetting new vendors, blah, 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 all that stuff. You don't have to do any of that. And why do I know this? Because I've been talking to you. I've heard this over and over again. It's like, oh, we want all this stuff. No one wants to do CQL anymore. They only want to use Mongo or, you know, something like that. Well, great. We got the data API. That's probably worth the upgrade right there, is never having to teach somebody how to do CQL anymore.
Yeah, no kidding.
But, you know, but the new use cases, like with vector search, also compelling. And you've really got to think like, do you want to go down this path? Because you're going to get asked. If you haven't been asked, you will be. How far do you want to go? And you're just going to make it easier on yourself in the long run. And then finally, my final pitch for Kubernetes. Really, I mean, it is the future. And if you think that Kubernetes is going to destroy your job, like you're never going to have a job anymore, when has an upgrade in technology ever made less work?
Right.
Because you know what's going to happen. They're just going to want more. So, yeah.
And that actually sounds a lot more challenging than it is. You know, one of the videos we actually have in our mission control playlist is, you know, kind of goes over, it shows, you know, Alexander Dejanovsky doing like 2 different install paths. And one is, you know, Kubernetes is already there. And the other is our path of bring your own Kubernetes. And he kind of shows how to do all that. And it's really not as complicated as you might think.
No, and you could do a live migration too. Aaron, yep. I think you should make that.
Oh, a live migration video?
Yeah.
Oh, that's a great idea. Yeah. All right. Yep. Yeah. I'll add one. Okay.
There we go.
All right. Of course, you know, check out datastax.com. We have all kinds of cool stuff out there. This is a blog post that Needy, one of our product managers, had put out there on, you know, introducing vector search for, you know, self-managed modern architecture. Really talks about the introduction of, you know, DSE and HCD. And then if you're interested at all, the code I had for the DS Books demo that I showed there, it's Java code, and it's using the Java client API as opposed to the Java driver. That's an important distinction there, because that client API is what allows you to use the data API.
Which is all HCDP, by the way. It's not a binary driver.
Right. All right. And Patrick, I think that's about it.
That's it. I don't see any questions out there, but you all know how to find us. We're not hidden. Feel free to reach out with questions, in mail, you know, tweet, whatever you're going to do.
Yeah, LinkedIn. Yeah.
LinkedIn. Yeah. Just hit us up. You know where to find us. We'll be happy to talk to you. If you want to get on a call, that's great too. I mean, we know that this is a thing. 6.9 is going to be out July 11th. So a couple weeks. And there's already a pre-release out there. You can grab it. There's an image. Yeah. So July 11th. And that's the release date, but you can get it today. That is available out there. And it's in like a beta release candidate type form right now. So this is pretty much what you're going to get. And it's a container. So we have a tarball too, right?
I think so. Yeah, there's a tarball.
Yeah, a tarball.
Actually, that's what I'm running too. I have the tarball locally.
You are such a nerd. Use a container.
I know, right?
But yeah, you can go get it now. And HED, same. They're both going to be at the same time. So yeah. Yep. Just in time for summer. Yeah, we'll put it in. Can we put a link up to where to get 6.9? Or maybe we could put it in the LinkedIn. You're watching on Crowdcast. So.
Yeah, I'm watching on Crowdcast. So I did see that.
Because you asked Martin, we're going to do it for you live right now.
I had the link somewhere, and now I have to find it.
Now I'm like, why didn't we have the link in the slide?
I know. We should have thought about that. Are people going to ask for the link? No.
Oh yeah, you go upgrade. Part of the fun is finding it. It's kind of like an Easter egg hunt. Hold on. Yeah, and then our producer Michelle, who's listening to this, we'll make sure and get it on all the platforms, because this video will be on YouTube live, or on YouTube. Our DataStax developers, the YouTube. So if you want to share it and that sort of thing, because you want to tell all your friends, right? Oh, we're going to go do this. And if you don't, what kind of nerd are you? Did you find it, Aaron?
No, I didn't find it yet.
Okay, Michelle got you. All right, we're going to share
Yeah.
this in an email because Aaron is failing. Isn't it
Yeah, I know.
downloads.datastax.com?
It's getting us back for the demo gods are getting us back for cheating them by posting that video, right? So
Yeah, I thought it was in yeah, hang on. Yeah, here it is. If you go to, I got it. You just go to downloads. Downloads.datastax.com, everybody.
yeah, that's it.
That's it. And here's a short link.
Cool. Nicely done.
Downloads.datastax.com. You can get HCD. You can get DSC 6.9. The release, all the releases are in there, pre-release. So go get it. Bandwidth charges apply. Maintain your carrier. All right. Thanks a lot, everyone. We're going to check out. You go check it out. Be in contact with us. We'd love to hear from you and hear what you think. So,
all right.
thanks, everyone.
Have a great day.